what's a system of equations? What are we doing? Your idea is to sub something in so that you can work with it, okay? If I start with quarters over here on the left, and I start with dollar bills over here on the right, every dollar bill you have over here, you might want to substitute in what? Quarters. So we're comparing quarters to what? Quarters, all right? So here's the whole idea today. Guys, section 5.8 is titled Systems of Equations. And we're going to look at this in an algebraic sense and also a geometric sense. We're going to use the idea of systems of equations to apply it to some geometry concepts. So goal-wise today, we are looking at modeling situations and solving equations with how many variables? What's it say? Two. We're going to just go ahead and talk about two today. All right? The example I used to start this today, we were talking about how many quarters, nickels, and dimes did you have. There were three unknowns. But for our purposes, we are only going to be discussing two situations or two unknowns. All right? First of all, we need to know what the heck a system of equations is. Very important. System of equations is the following. It is two or more equations which state relationships that must be true at the same time. So as an example, right up here I have one equation, I have a second equation. What's the first equation in this? Y equals 3 times x. How many variables are in that first equation? Two, a y and an x. Okay. What's the second equation?
X plus y plus 40.
X plus y plus 40 is 180. Okay? So what you need to understand is this. It's two or more equations. We're only going to be talking about two equations today, which state relationships that must be true at the same time. What it really is two equations with how many unknowns? How many variables are in each? Two. Two equations, two unknowns. In this case, we're going to have to solve for an x, and we're going to have to solve for a y. Now, the solution of a system is simply an ordered pair of values for the variables found in a system of two equations that makes both equations true at the same time. So take a look at what I have over here in the box on the right. It says the solution of the above system is x equals 35 and y is what? 105. Watch what I do here. Guys, it says anywhere where there's an x, x has to be what value? I'm giving you the solution. I'll show you how to find this in a second. But what's it say the x value has to be? 35. So in this top one right here, I'll kind of zoom in a little bit. In this top one right here, what did I say the x value is?
35.
And what's the y value? So where I have y right here, this would imply that 105 has to equal 3, part of my equation, times 35. 105 has to equal 3 times 35. That's what that means. So by saying this, check it out. If I go into my calculator here and I punch up 35 times, what did I say, 3? Does that give me that answer of 105 over here? Okay, so did 35, when I plug 35 in for x and 105 in for y, did that give us a true statement here? Does 105 equal 3 times 35? Well, it does, right? Okay. Now on the next one, same thing is true. It's saying the following. We want the x value to be, what did I tell you the x value was? So they're saying down here that 35 plus what would take place of y according to the solution that's given, 105. That has to add a 40. This should equal what value? 180. Okay. Guys, notice in for both x's, what value did I put in each time? 35. And what did I put in for y each time? 105. Okay. When I add these values up, 35, 105, and 40, does that add up to what we were supposed to equal here? Did I get a true statement there? Okay. Here's the deal. A solution to a system of equations is two numbers, one for x, one for y, that's going to make both equations true at the same time. Okay? Kind of like what we had up here with quarters, nickels, and dimes. If I had 2 quarters in one setting, you had to have 2 quarters in the next setting, right? It's kind of like saying up here, if x is 35 up here, what's x have to be down here? If x is 35 up here, what's it also have to be down here? 35, okay? All right, so let's see if we can't figure something out here. Let's go back to that first example down at the bottom and talk about this. First thing I need to do is make sure I label my triangle correctly in this diagram. So you guys will want to do the same thing on your notes. It says in triangle ABC, the measure of angle B and C are the same, and angle A is twice the measure of angle B. Find the measure of each angle. Okay, I'm going to come back to this here in a little bit, I think. But I want to go ahead and label my triangle as follows. Let's go ahead and say that this is angle B up here. And that's angle C. But we're going to call this angle A right down here. Okay. Come back to this here. This is going to be important to understand here in a second, but just get this labeled A, B, and C, all right? Better yet, let's roll it. Let's roll it. What the heck? What's it say is true about the measures of angle B and C? They're the same. Do I know how many degrees angle B is? I don't. So what might I throw in there to indicate a degree measure? Well, do we know what it is in this problem? We don't have a clue. So I say I don't know what angle B is. So maybe I say it's x degrees. Is that okay? What's it saying about angle B and angle C again? They're the same. So if this is x degrees, what's this have to be? Same, right? Everybody agree? Now, in that statement, what's it say about the measure of angle A? What's the measure of angle B according to what we've got written up there? X. So what would twice of x be to get angle A? 2x, wouldn't it? So doesn't that make angle A down here have to be 2x? Would you guys agree?
Yeah.
Okay. What's the problem asking us to do?
Find the measure of each angle.
Find the measure of each of those angles. Boom. Right there. Find the measure of each angle. All right. Hey, we talked a while back, earlier this year, it says, angles, triangles. They add up to a certain value. Did I write an equation for this? Okay, now keep in mind. Keep in mind. I just told you we're going to be talking about systems of equations where we're going to have how many equations? 2 with 2 unknowns, right? Okay. I wrote everything up there in terms of x, so isn't x the only thing that's unknown right now? Okay, but how many separate angles are up here that we don't know right now? Okay, that's where some of that stuff is going to come into play. So understand we're trying to find 3 things here again, right? Okay, so watch what I do here. All 3 of these expressions should add up to equal what value since it's a triangle again, you told me? So my equation, here we go. I can say 2x plus 1x plus another x had better equal a total angle value of 180 degrees. All right. Ooh, I like this because what are you going to get on the left side when you combine some terms? How many x is that?
4x.
Yeah. 4x is my 180. All right, you guys perform a division for me real quick. Let's see what you get. How much? 45. Good. Good, good, good. So right here, gang, we already know that my x value is 45. Now, I want to go back to the question here. I want to go back to the question up here. It says to find the measure of each angle. All right. Angle A right here says to take 2 times x, doesn't it? Angle B is equal to x. And angle C is also equal to x. Okay, well, if angle A is 2 times x, that implies 2 times what? What do we get for our x value here? That implies 2 times 45, doesn't it? Right?
Yeah.
Okay, so 2 times 45, what have you got for our product?
90.
Good. So angle A measures how many degrees? 90 degrees. Okay? Well, if b is just equal to x, then this is just equal to what value? 45 degrees. And if c is just equal to x, what's that equal? Got a question here. Actually, two questions. Are angle B and C equal? Is angle A twice the measure of angle B? Okay, how can I know I'm right with those values?
Add them up.
Add them all up, and they better get me back to what value?
180.
180. Do they?
Yeah.
Okay, yeah.
I just saw that angle A was a right angle, and so then I did 90 divided by 2.
Okay, that's cool. When we start looking at examples that have an obtuse angle in there and we don't know it's 90, and they start describing stuff like that, is that always going to work? No. That's a great observation, Laney. Okay, that's a great observation. And I think when we look at the next geometric figure in a second, you'll understand why we're going to choose to do it this way. But as long as you can take what we did here and say, hey, does that match what you thought about? Okay, so will this process match the things that you thought about right here then? So we're good to go, right? That's great though. Okay, so good. Good. So knowing that is that I can go through this knowing I better get these for answers. And did we get the answers you thought we should get? Okay, awesome. Questions about that example? Okay, let's get to the meat of this today and talk about what's really going on. Drill and practice type stuff right here, guys. Okay. Give me something back that's equal to that. Monetarily. I don't want a phone. Alright. Do you have $10 and ones and fives? Do you really, Brianna? Oh! Brianna does. If I need a new truck today. Got that money. Tell you about three short. What puts you like 4 or 5 ones short?
Dang it.
I have a $10 bill. Okay? I'm going to give this to her. I still have $10, but do I have a $10 bill anymore? Brianna's giving me 5 ones and a 5. Do I have the same amount of money?
Yes.
Okay, monetarily the same amount. Okay? Basically what happened is I substituted that $10 bill for a 5s and some 1s. This $10 bill is like one expression. This is a different expression, but they are the same thing. I'll bring your money back, I promise. Okay? At a later date. Okay.
After, yeah.
This 5M up here kind of represents the 5s and the 1s right up here. Can you guys all see that? This N right up here represents the $10 bill. Okay? Guys down here, do you have an N right down here?
Yeah.
How many of them?
3.
Couldn't I put this $10 bill down there where the N is and take it times 3? I could, couldn't I? Or, this is my 5M over here. Could I put my 5M down here? They're the same thing, right? Right up here, this says that N is equal to what, gang? N's equal to what? The N is like my $10 bill I hold in this hand. The 5M is like this mess that I hold in my hand. Regardless, N is the same exact thing as 5M, right? This is my N mess, this is my 5M mess. They are, what's the sign I'm pointing at?
Equal.
Everywhere where I have an N then, what can I replace the N with? Okay, keep that in mind. Thank you, Bree. That was good. Okay, hear me on this. I'm going to zoom up. Okay, you guys, what did I just say in that first equation? Well, I said N is equal to what? 5M. In example 2, it says solve the following systems of equations. And here's the shortcut I'm going to give to you. Okay? First of all, how many equations are up here? 2. Okay. 2 equations. What I want you to do is circle the letter that is all by itself on one side in one equation. So is there like a 1n or a 1m all by itself on one side of the equal sign in that equation? Where is it? Okay, this n is all alone right here, right? Circle that. Okay? That's the variable we're going to substitute for in the next equation. What does it say I can replace an n with? In other words, what is n equal to? So anywhere where I have an n, I can replace it with 5m. Now, this idea of substituting, if I ever substitute some kind of a variable expression, you will always substitute with these. So if I ever change something, ever remove a variable and replace it with some kind of equivalency, put what around the substitution? Parentheses. Okay, listen to me carefully. Since this is the equation up top that I identified as saying n is all alone and it's equivalent to 5m, you're going to come down here and rewrite the second equation now. And this is how it's going to work. What did I circle down here, or up here that was all alone? So circle the other n down here. Okay? What I underlined is what I'm going to substitute in down here. All right? Notice my second equation. How many different variables are there? Well, there's an m and there is an n. Okay? This would be nice to solve like this example where I had all x's in here, right? Wouldn't equations be easier to solve if they had all the same variable in them? Okay, so look at what we're doing here. I am saying, hey, n is all alone up here. It's equal to 5m. So if I have an n down here, what can I replace that n with?
5m.
Okay, so where I circle right here, so you know what? We're going to replace that n with 5m. And here's what the second equation is going to look like. This is going to become the 2m that's already here. Plus. Now isn't there a 3 in front of that n that we're going to replace here? Plus 3. Okay, what is n equal to again, guys?
5m.
So what can I replace the n with?
5m.
That's like taking a $10 bill and replacing it with a 5 and 5 ones. They're the same thing, right? They just come in a different form. So right here is where my parentheses go. And right here where those parentheses go, there was an n. What are you going to put in there?
5m.
Why are you putting that 5m in there?
Because it's replacing.
They are the same thing. Notice, I had an equation with m's and n's in it. Now I have an equation with just m's in it. And that's going to allow us to solve for what? That's going to allow us to solve for which variable now? What's this still equal to in that second equation? 51. Okay, kiddos, help me out. Help me out in this first step. What's 3 times the 5m going to be then?
15.
So we're at 2m plus 15m equal to 51. Guys agree?
Yeah.
All right, looking at combining like terms now. 2m, 15m, where are you? Is what value? Hey, I got a question here. Are we able to solve for m at this point? What's m equal? You're going to take 51 and divide it by? What'd you guys get? 3. So the m value is 3. We know what m is equal to now, right? Okay, so listen carefully on this. I figured out what m is. What do I need to do now? Figure out what n is, right? I'm going to change colors, all right? Once you figured out one variable, go back up to your 2 equations. Find the equation that appears to be the easiest to work with. Of the 2 equations that are up there, which one appears to be the easiest to work with? First one or second one? First one's the shortest. So I'm going to choose this equation. I'm going to put the rest of the work over here. I'm going to say, you know what? We knew that 5m was equal to n. And here's the beauty of this. I say pick the one that looks easiest to work with. Here's the real beauty of it. It doesn't matter which one you pick. Either one, you can't go wrong. You're still going to get your answer. I just picked the one that looks like it's easiest to work with, right? It's like a Ford over here and a Chevy over here. Duh, Chevy, right? Right? Okay? Well, that's probably a bad analogy, but anyway. All right. Well, hey, right here, I'm saying use that first equation. Let's do something here. Guys, this says 5 times m equals n. But what do we know here in red?
M equals 3.
So what can I plug in for m? This means that 5 times 3, after I substitute that 3, because that's what m is, right? Equals n. Okay. How about 5 times 3? What is that?
15.
It says 15 is equal to your n value. Help me out here. I know it's true for this. When I put 3 in for m, and 15 in for m, 3 in for m right up here, 15 in for n up here, do I get a true statement? I do. Okay? Check this out. What's 3 times m, I'm sorry, 2 times m right here? To be honest, 2 times 3, wouldn't it? Wouldn't that be 2 times 3? This would be 6, wouldn't it? What's 3 times 15 right here, or 3 times n? Oh my gosh. The 6 and 45 add up to 51? Does. What value for m and what value for n made both equations true at the same time? What was the m value? What was the n value? 15. Okay? Let's try another one here quickly. Guys, we don't have advisory today, do we?
Friday.
Okay, Friday now?
Yep.
All right. All right, let's see if you guys can talk me through number 2 here. Guys, which variable do you want to circle first? Y. Okay, y is equal to what I'm going to underline. What is y equal to? 2x. So the one that I circled and underlined is in the bottom equation. So which equation am I going to have to work with to solve for a value? Well, you'll have to work with the top one. Since I circled in the bottom, we're going to work with the top. So what variable did I circle on the bottom? Y. Underline its equivalency of?
2x.
Okay, so that 2x is going to replace what up top? The y up top. So what's my new equation going to look like up top? Somebody tell me. Brittany, what do you think, kiddo?
7x plus 3, and then put 2x in parentheses.
2x is going to replace the y in parentheses. Great.
Equals 13.
Are we good? Yep. Right here. Y is equal to 2x. So what can I replace this y with up top? 2x. They're the same thing. Okay. Roll. What's 3 times the 2x there? So I've got 7x, part of that problem, plus 3 times 2x is 6x. What's that equal? 13. Yee! What's 7x and 6x going to add up? This is fun. I'm having fun. Does that make me a nerd? Well, you know what? I'm a nerd and I'm happy. I'm a happy nerd. What's my x value going to be? 1. Yeah. This isn't that bad, is it? Oh my goodness. What's your x value? 1. How are you going to use x to find your y now? Well, which equation do you want to work with now? The first one or the second one? Second one looks shorter, doesn't it? So I'm going to go ahead and rewrite that second one after I found one value. You know what? The equation I'm choosing to work with, y equals 2x. Now once I found one solution, I should be able to substitute that in for one of the variables over here. What did you know right there? You knew that x is what?
1.
So what can I transfer up to here? I can transfer a 1. Okay, so right up here, we're going to say, you know what? This is the same now as y equals 2 times 1. Well, a hot digging a dog, what is 2 times 1? Okay, so for both equations to be true at the same time, what does x have to be in each equation? What does y have to be in each equation? 2. Check it out. 7 times 1 in this top one, what is it? 7. 3 times 2 right here, what is that? Does 7 plus 6 make the 13? Works! What am I suggesting to you in this set right here? Find the variable that's all what? Alone. Underline what it's equal to. And then go up there and find the variable that you circled. Circle that and replace it with the underlined part. Thoughts? Questions? Ahas? Too gosh darn easy, Parson, we need harder work? Lauren shaking her head yes? I was looking at you sideways. Okay. Alright, alright, alright. Is there more?
There's one more.
Oh, goody. Well, I'll tell you what I'm going to do, kiddos. I think I'm going to finish up this third example here. And I think that would probably be a pretty good place to stop since we're running out of time a little bit. And then we'll record part 2 of this tomorrow at the very beginning. But I'd really like you guys to see if you can talk me through this. I'm going to ask some questions. You have answers. What letter am I going to circle first in this problem?
R.
I'm going to circle R, right? Because R is all alone, isn't it? Now, what expression, or what expression is R completely equal to? The S minus 4. So everywhere where there's an R, what all do I have to put in? Okay, so I'm going to come back down here and circle which variable? Okay. So help me out here, kiddos. How am I going to rewrite my second equation?
5, and then put in parentheses S minus 4 plus 2S equals 8.
Okay, would you guys agree right here? This R right here that I circled in the bottom equation got replaced with what?
4.
S minus 4. Now this time we kind of substituted a binomial in there. No big deal. We know how to handle this when there's a coefficient out front of there. What property will you apply? Distribute. So help me. 5 times S. 5S minus
4.
5 times 4, kiddos. Careful on that. 20, right? Plus the 2S still equals what value? Good. Hey, looking at the left side, how about my like terms now? Any like terms? 5S, 2S, both positive would get me a 7S. Minus 20 is equal to what?
2S.
Equal to 8 up here, right? Hey, we're on a 2-step equation. Add 20 and divide by
7.
Okay, so help me. Let's do this all in one step. Add 20 to 8. What do you got?
28.
And then 28 divides 7.
4.
So what's the S value here? S is equal to 4. S is 4. Okay, good. What else do I need to figure out? Well, do you want to use the top equation or bottom equation to figure out R? I'm going to use top. So I'm going to rewrite the top where I said R was equal to S minus 4, right? Well, from the previous solution, what did you know here? S is 4 could transfer up to here then, right?
4
So
minus
R will
4.
become what minus what?
4 minus 4.
Yep.
Equals 0. Oh boy.
How you guys feel about this?
Pretty good.
Okay. Make sure you have everything down. I'm going to stop there. Bring your notes tomorrow. We've got a couple more to finish up. The assignment again, due Friday. Okay? Did I tell you due date yet?
Yeah.
Due Friday. We got a few things to finish up tomorrow, but bring them with you. Good job today.